Hi, I'm an old guy and I do maths. Today we're looking at the differential of the natural log function. And there's no surprise here because the answer to what the differential of this is written here. So if you completely understand how we got this, I don't think that there's any point in watching any more of this video. Unless you're interested in the explanation and the consequences of that explanation, because the explanation has consequences for not just differentials, but it enables us to see where the integral of some functions come from. We'll get into that. Right. Okay, so let's start with this. So the differential of log e to the x is 1 over x. So what we have here is we have log e and the function of x. Right, so why is it so? Well, the chain rule helps us explain that. So let's just get into this. This equals dy du, du, dx. Okay, so the first thing we do is we call this u. So u equals x, and obviously du dx equals 1. Now, what's the differential of this? Well, dy du would be 1 over x. So where does that get us? Well, nowhere fast until we look at the second part of this. We have decided that the differential of this is 1. And so, because we just have a single x here, the differential of this, which I'm sorry is getting a bit messy with all of my circling and scratchings, is 1 over x. Now this is why. It's also why the differential of this is 1 over x. So let's have a look at how this works. Okay, so we can take a couple of shortcuts. We've got our differential of this. Right. But what's the differential of this? Well, it's 9. And so you can see where this is heading. We wind up with 1 over x. Now, this has a number of interesting consequences. I'm going to do one more of these. I'll just get myself some fresh paper. How about we take a look at this, log e 3x plus 2, or some similar sort of problem. Now, cutting straight to the chase, basically what we wind up with is 1 over 3x plus 2 times 3. And so the differential of this is 1 over this times the differential of this, which gives us 3 over 3x plus 2. Now, those of you who've had experience with anti-differentiation will notice that, in the past, no doubt, you will have been given problems that look like this, and you've been asked to integrate them. Well, seeing what happens when we go from here to here, you can hopefully now maybe understand why the antidifferential of this might include a log. If you look through your cheat sheets and things like that for differentials and antidifferentials, you'll see a pairing like this somewhere. Now, where can we go from here? So there are a couple of rules and guides that we can generate from this, which saves the bother of the chain rule. So we can write a general rule, something like this. So there's our function of x, and dy dx is going to equal a, the differential of this, over ax plus b. Now that is all provided that this holds true. So negative b over a, x has got to be greater than negative b over a. Otherwise, sorry, we'll just get that into frame. X has got to be greater than negative b over a. Otherwise, we're in uncharted realms. So just bear that in mind. That's a little test. So that's one way of looking at this. Right. There's one other, and this is a big one because I don't know about high school, but certainly by the time you hit university, you'll see this. Now, how about that? Think about it for a moment. Just think about it for a moment. So the differential of this can be written as the differential of this, which is, in this case, 3, over the function, which in this case is 3x plus 2. That gives us our answer. There'll be more on this in other videos, but this is one way of looking at this, and it explains several things. It explains why, for instance, the differential of log 5x is 1 over x, when the differential of 3x, log e to the 3x, is 1 over x, and so forth and so on. And again, for those of you who are a little further along and have looked into antidifferentials, it explains why the antidifferential of this looks something like this. Okay, there's a lot in there. Thank you very much for watching. I hope you found this instructive and useful. See you next time. Bye.